So first of all, today is homework week 3 deadline, right?
Yes.
So maybe something around that. And I was thinking about talking about the 2 errors that everyone seems to be having with BigQuery while using dbt. What do you think? Okay. Now?
Do you want to share your screen, or you just want to talk about
No,
this?
I don't have them. I don't have the errors. But I've seen that there are 2 errors that people are having. One is around something like, no, they don't have permissions when trying to run. It says something about blobbing. For this, check the service account, because it's probably the admin rights are not right. So either they didn't use BigQuery admin and then they use the other ones, which is okay, but then should maybe a review regarding, so checking again the setup file that we have in the repo, or use directly BigQuery admin and maybe download the JSON and upload it again. Try to do the connection again from dbt cloud. But it's definitely something around that when you have an error that you can't run. The other one is about the regions. And for this one, it seems to be that when you're using BigQuery, the default location is something different to the one that was being used to generate a trips data. So for example, for me, I generated trips data, and this was in Frankfurt. And although I thought everything in my account was in Frankfurt, for some reason, my schemas were created in the US. This could be because either you didn't generate it manually, or you generated manually, but then that was the default location. So just drop the schema, which in my case, for example, in my video says dbt_Victoria_Mola. So it would be something like that, the development credentials, drop it, create it, setting the actual location to match the one in trips data. In my case, it was Frankfurt, but it could be anything, but it has to be the same one. And the explanation behind the error is that it's trying to do a multi-region query. So it's trying to select from a region and trying to insert into another region, and this is not allowed. Something that I would do to debug this kind of issues, or issues in general when you have one running, try to use the compile code and run it yourself, and you'll run into the same issues from BigQuery. That's all I wanted to say. Those are the main errors I've been seeing that they keep appearing.
I'm smiling because there is a comment about the performance hoodie.
You miss it. And last week as well.
Yeah. So last week it was in laundry. It's still, so I don't get any comments like I don't wash it or anything like that.
It's not like someone can smell it from the other side, so it's okay.
I'm only wearing it like for 1 hour per week or for 2.
Yeah.
Okay. Do you want to say anything else before we start with questions? No?
Not for
I still
from my
want
side.
to try the Docker setup. I haven't tried it with dbt. That's something I still want to try. So because I saw that there are questions about that.
Yeah.
So yeah, I'll give it a try myself and see what's there. So maybe I can also say a few words about the Spark Week, which was supposed to start today, but since there was some delay, well, good news is I'm already preparing the materials. So I have some draft here, like what exactly we'll cover. I will post this on GitHub soon. But yeah, videos are not ready. This is something I plan to do this week. Yeah, I tried it on Linux or Windows. Now on video I will do this with Linux. If somebody already wants to do this on Windows and test it, there were a few messages from people who are taking the course saying that they can help with testing the environment. So if you have Linux or Windows and you have a bit of time because you already finished week 3 and week 4, you can ping me or write this in Slack in the channel, and then I will share these instructions with you so you can check if the environment works well or not. And yeah, so I will probably not spoil it, spoil the surprise. You will see the video soon. Yeah, that's for Spark. And for BigQuery, I think the deadline for this for the homework is today. I don't think we recorded the answers yet, the solutions. So should we keep the form open before we record the solutions?
I think we should follow the deadline. We can release the solutions, but it would not be fair for.
Okay. Okay. So now let me open the questions. Okay. So the questions we have. So what are similar tools in AWS and Azure for dbt?
I mean, you would just, again, set up a warehouse, and then at the end, you just connect, define the connection. The only difference is that you would have to use the adapter, but dbt has several adapters. So what I would do first, if you want to use dbt, is go check the adapters and make sure that it's supported. Yes, I was going to Google that. Perfect. Adapter, yeah. That one. There are several that are like official, all of this. So for example, Redshift you could use, yeah. And there's some, can you vendor support it? And there's some others like community supported, and that's where Azure is.
And this is AWS,
Athena.
so Athena.
Yeah.
So Azure and Athena are here. Then, yeah, Redshift. I think I saw Presto, Redshift, yes, and Presto. So for example, we have a Presto cluster. So we use AWS, and within AWS we have our own Presto cluster. So then you can potentially, so if you have a similar setup, then you can connect dbt with Presto.
Yeah, and in general, to add a little bit more to the answer, let's say you have the project right now and you have it in BigQuery, and what you would do is try to change the profile, and that's it. And you set up the connection, and you may have to do some changes in if there's something in SQL that's supported in BigQuery and not the other way around. But other than that, you will be able to run the project in a few minutes.
Okay, thank you. So I am marking this as answered. What is a data mesh, and will it be covered in this course?
It's in the buzzwords, right?
Yeah, it is. If we go to data engineering Zoomcamp, so we will not have we will not have like a practical week about this. Yeah, upcoming buzzwords. So it will be more like a 5 to 10 minute video explaining what it is and when to use it. But that's what we plan for this, not more.
Yeah, maybe you can spend a couple of minutes on it today also.
Yeah.
Do we have a lot of questions? It doesn't
seem like we have a lot of questions, so you can go ahead and spend a couple of minutes on it right now.
Yeah, exactly. So data mesh is basically a concept, and the idea is, well, let's go back and say how are the data pipelines and the data engineering teams built in different companies right now. So it's basically like you have people who are generating the data, there are people who are consuming the data, and then there is this one big team in the middle, which is called, let's say, the data engineering team, data ops team, or whatever you want to call it. Different companies have different names. And these teams are responsible for ingesting the data, transforming it, putting it out there, and making it in the way that it's consumable in the right way, in the right fashion, and all that. So what data mesh wants to do is basically wants to decentralize this particular role of this big team, and want to give the power or let's say the responsibility to the team who are generating the data and their teams that are consuming the data, and not have this layer in between. So instead of the team taking the whole role and doing this, it's kind of like a better idea to build up services and then give the responsibility or give those services as a software to these teams who are generating the data and consuming them, and basically going out on a higher level with respect to this. So in this case, what happens is basically the team who's generating the data is responsible for the quality of the data, for answering different questions from the data, and all that things. And that's really useful because when you have multiple teams handling the data, the idea of the data, or basically the knowledge of the data, is lost. The best person or the best team to answer such questions, or the best team to have the knowledge of the data, is the team who's generating it. So if they are also responsible for putting the data into the data lake or data warehouse, and then also responsible for the queries, then it kind of attaches this whole thing together. And that's kind of a very rough idea of data mesh.
It's very abstract concept.
Yeah.
We actually, if we go to YouTube channel, there is a longer explanation of data mesh. And by longer, I mean 1 hour long, 1 hour and 6 minutes. So if you're into this kind of stuff, and by the way, this one, DataOps 101, is also quite a nice one, so you can check this out as well.
Yeah.
And this one, modern data stack for analytics engineering, this is also good. So basically, yeah, you can check these three, they're good. But if you're interested in data mesh specifically, the first one goes in a lot of details, the second one in a bit of details.
And there's also a very nice blog post.
How do you remember the name?
Just Google data mesh.
This one?
Let me check. Yes, I was actually
from
Martin Fowler.
Martin Fowler.
Yeah, from Zhamak, right?
Yeah, Martin Fowler.
Okay. Yeah, Zhamak is writing actually a book about this right now. I think it's in early release, and she's written like 5 or 6 chapters. I don't remember, but yeah, it's in progress. Probably it's going to be quite a big book, right?
Yeah, this blog post itself is like 2 days read. So I read it in a couple of days. It was impossible to read it in one go. It's huge.
I think you can also download the first 2 chapters or something like that of the book, and they give like a big overview as well.
I think I downloaded something, data mesh in practice.
Yeah, I don't remember do you remember how the book is called that she's writing? I think it's just data mesh something, like the concept or something. Data mesh book.
Yeah, it's called data mesh.
Yeah, there's also another book by O'Reilly. It's Data Mesh in Practice by Max Schulze.
Yeah. So this is so Max was the speaker. I don't know where it is. Data mesh. And this one is free, right?
That one I don't know, but it says report, so it would make sense, right?
No, I think it is free.
It's free.
Okay, go away. Okay, are we done with that much?
I would say so.
Okay, how restartability and incremental loads usually made in BigQuery? In Redshift, there are stored procedures. What is the approach in BigQuery?
I think there are 2 parts here. One would be how the data, I can talk from the part that the data is already in BigQuery, because we can do this with DET. And the other part would be the loading the data, right, incrementally. So in DBT, there is a third materialization that I briefly mentioned it, but I didn't go into details while doing the project because it's more like advanced. And it's called incremental. And what it does is exactly this, right? So your model is a table, it's materialized as a table, you'll find it as a table in your data warehouse, but it allows you to use an incremental block where you would define what is new data for you. And every time you run the model, the first time you run it, it will do the create table as select from everything. So selecting entirely everything from the source. But the next time you run it, it will insert only the new data depending on this incremental clause, because you have to tell, right, what is new data. So let's say you have a loaded timestamp, then you can do select everything that the timestamp is greater than the max timestamp that you already have in that table. And that way you load incrementally. Also, it's very useful because most likely you don't need to reprocess. Let's say in our case, we're processing trip data. And let's imagine that we are processing this trip data every day because we work at the company of the taxis in New York. And we don't want to reprocess the trip data for the past years. We just want to process the new data that just came in. So then it makes sense to also do it incrementally instead of applying the whole business logic all the time to the whole amount of years of data that you have. I think that covered that part. Ankush, do you want to take the other part? If there's any other part from your point of view?
So what does it mean by restartability? Does it mean like loading all the data, or?
Yeah, I understand that, at least. Like, because also you can, if you do it incrementally, there's a point where you want to refresh maybe. And then that's what I understand from restartability. And then you would like load everything from the source.
Yeah, exactly. So it would be the same way. Basically, you can choose the different time ranges, or you can just say no filtering and just give me all the data. And in that case, the table will be created from there with all the fresh data, basically. And to make it an atomic operation, just remember to create or replace table. So that's an atomic operation. So there would not be any issues if there are queries which are already running.
You mean this
I don't know if,
right?
Yeah, that's the. So I don't know if that was the question or not, but I think that's what it is meant by restartability or something.
I have nothing to add because I don't know this. So I am solving this. I am having a hard time differentiating between data warehouse and data lake. Could you please quickly recap it? Does somebody want to try it?
I would say the video from Ankush was a nice recap.
Yeah. Actually, that was the recap.
Yeah.
All right. So data warehouse versus data lake. Let's just go through the quick differences quickly. So data warehouse is basically meant for structured data where you already know your schema of the data. You already know how different tables interact with each other. You are kind of pretty sure how will your future data look like, and you're not changing that on a very regular basis. And in those cases, data warehouse is the perfect solution. You dump, or not dump, but you put your data in a particular schema nicely into your tables in data warehouse. And then you can basically query across huge amount of data with respect to joins or different SQL queries you have on top of that. And this is basically the concept of data warehouse. So you have a schema, you already know everything. Your data size is generally in, let's say, terabytes, not petabytes. And basically, you have like long-running SQL queries working on top of them. When it comes to data lake, the basic idea is that you do not know what kind of schema you have. You do not know how is this data being used in the future. And what you really want to do at this moment is to save the data as soon as possible in a place which can be used in the future or can be used for different use cases which are maybe not covered right now. And in those cases, what you will do is basically you will take your data, whatever schema it is, doesn't matter. It can be JSON, it can be Avro, it can be Parquet, it can be whatever. It's good to have some standards, but even if it's not, you can still dump that data to a cloud storage or a S3 bucket or an HDFS instance, and basically dump your whole data in whatever format you want there. The idea should be that this data should be recoverable. So you should have some sort of metadata attached to it so that this information is searchable. You know what the column names are, what it means, so that if another team wants to interact with this data, they can. And basically, with data lake, the idea would be that, hey, I don't know what the data is, what is the use case right now, but I dump it. And then tomorrow or in 1 year, data scientists or data analysts comes up, uses this data, sees that this information is available to me, maybe transform this data and put that into a data warehouse or put them into a different bucket and then reuse it. So a use case typically can be like a machine learning model, which collects a lot of data over years. And then let's say you have data for recommendations or data for people buying different products for the last 5 years. And then you can build up a recommendation system on top of that. But if you lose this data, then basically you cannot generate these kind of models. And that's where data lake really plays a vital role. Did I miss something?
Well, that is a pretty comprehensive recap, right?
Yeah.
I think it was not a quick one.
Yeah, but at the end, I mean, also think about, I think what does the trick for me, a silly trick, is think about the word, right? Like, how do you store things in a warehouse? How do you store things in a lake? You don't, you just have them, everything, they are available. So kind of like the image, or at least for me, explains, helps me understand the concepts as well. Like in a in a warehouse, normal warehouse, you would have like the shelves and things of structure, and this is also how it looks like the data in a data warehouse, kind of.
And the way I understand them, maybe this is not the best way of thinking about them, but data lake is your file storage, right? So you write Parquet files, so it could be S3 or Google Cloud Storage or HDFS. For us, it's HDFS. And then you have a bunch of buckets, and these buckets have some structure, but this is just a bunch of files, right? So these files are documented, they adhere, they follow the same schema more or less, but this is just a bunch of files. So something needs, if you want to access these files, something needs to go there, read these files. So it could be a Spark thing, could be Airflow thing, could be a simple Python script, but it's just files, right? When it comes to a data warehouse, it's not just files. It is a thing like with, how to say, like it's properly structured, right? So there are tables, you know, the schema, there are some use cases, and then it's faster, right? Because for data lake, usually you need to, I don't know, download these files, do something with them, put them somewhere, and data warehouse is optimized for the specific analytical queries you have. So let's say you want to write to create a dashboard, and then in the data warehouse you model this data in such a way that it's relatively fast to do this. So you don't need to go there, download the files, run aggregations. It's a lot easier. So this is how I understand the difference. And then a very quick recap would be files dumped on S3 data lake, nice schema in a database. It's a data warehouse. Or it's too much of a simplification.
I think it explains the big difference between data warehouse and data lake, which is like the bigger concept, right? And then from there, you can always go deeper.
Okay. Can you quickly summarize how to upload data to Google Cloud Platform without using Airflow? I can try doing that. So first, there is transfer service, which if you have an account with AWS, you can use this. The reason you need an AWS account because it asks you to enter your keys, like secret, like access key, secret, whatever. Like you basically need to do that, even though the data is publicly available. You still need to do this. And then there is an alternative. I think this is actually something that Sejal shared. So this is the script that you can use. You just run it. Preferably you run it in a cloud virtual machine, then it will be quite fast. And yeah, you just uncomment what you need. So let's say if you need to have green data for 2019, you run it, and for yellow, if you need yellow data, uncomment it. So this script is doing, it is downloading the file, it's saving it to CSV, and then it's also saving it to Parquet. And then I think what it's doing, it's uploading the Parquet file. If you need to upload CSV, then you can probably replace it somehow. Yeah, probably comment the Parquet part. So yeah, this is how you can do it without Airflow. Probably the easiest is transfer service.
I also did something similar, like the script from the shell, and then I just not the best way, so maybe not super advanced, but and then I just drag and drop all of the CSV to the backend, and then from the backend you just do the select that anchor shift spline, and it's which is on the first videos, I think, out of all of the videos from week 3, and yeah, also have it.
So you downloaded the data with a script, and then you just select all, drag and drop to Google Cloud Storage, and that's it. Oh, that's smart.
Yeah, not the best way, but I didn't have a data engineer, so I had to. I had to get that data somehow. But yeah, and then I think in general, I guess like the question is very much targeted about what we are doing, but in general, there are so many tools that you can use as well. So I think we mentioned some, like at least I mentioned Fivetran and Stitch. But yeah, in general, any other tool like that could be used.
Are you answering the second question already?
Oh, really? Is there a way to transfer data? Okay, without Airflow.
It looked to me like you were already answering.
Yeah. No, I haven't read it. Technically, your part of the answer also was without Airflow, so I would say we can mark this one as completed. And as Ankush, yeah. Do you want to encase from a data engineering perspective? Would be nice.
No, I think that's perfect. I could not catch the whole answer because of internet issues, but from what I heard, I think I'm convinced.
But without Airflow is what you show in the videos, right? So this what was insert into something, and then you do select the star from external table, and then this inserts data, right?
Yeah, there's also a way to directly upload it to BigQuery, but I just chose the external table because that's easy.
Okay, question from Mikhail. Why is a table in BigQuery called an external table? Probably there are 2 questions, so let's start with this one. So why is it called this way?
The reason this is called this way is because the data itself is lying externally in another storage, like Google Cloud Storage in our use case. So once the data is imported inside BigQuery itself, and BigQuery saves it in its own format, whatever the format is, that's basically that will basically be an internal table to BigQuery, and that will be normally just called a table. But for the data when it's lying outside BigQuery, for our like in CSV formats, and in this case, they are basically called external tables because the data source is external.
And so external tables, I think they are slower, right? It's also more expensive to query them, right? So in general, we would use these external tables only as a temporary place where we would keep our Parquet files before they go to our data warehouse, right? Exactly.
So generally, that's definitely one of the use cases that can also, like, you can also use it to load it into your internal tables. You can also use it to do some quick analysis, like your data is correct or not, and things like this. And also you cannot build external tables with partitioning and clustering. So that can be a big problem for future.
And if they drop that, so in this case, the bucket is ours and all of that, but you could technically have a bucket that someone shares or something like that. Then if they drop it, you lose it, right? Like you lost that table entirely because it was not your storage. It was not in your storage, so then you didn't own it technically, right? Yes. I think that would also be something to consider.
So the external table, so external table is just a metadata information, right? So the metadata information would still exist if you create it once. But if you try to query the table again, basically select star from this particular table, which is not existing anymore because the data source is deleted, the query will run into issues.
Yeah, I run into these issues. So it says the files, something like source does not exist or something like this, and it just refuses to execute the query.
Exactly.
And then the second part is, can you quickly run through the difference between an external table and a materialized table?
So did we already do that? Kind of.
I don't know. Did we?
No.
What is a materialized table?
Isn't it a materialized view though? I'm confused with the concept.
I know a concept of materialized view. Yeah, not sure
Me
about
too.
materialized table. But
Um,
materialized
From my
view
understanding,
is. Sorry, I'm
It's
checking.
a table, a materialized table. Every
so
table
for
is a
me,
materialized table, isn't it?
exactly. So that's why I
Yeah.
said we answered it because that was. I think that's
Yeah.
what the meaning from this question was. Basically, external table versus internal tables.
Okay. Because there is a concept of materialized view, which is like when you have a view, and view is nothing else but a SQL query that is executed every time when you want to do something with a table, well, with a view. So you are kind of querying a query, and the way to speed it up, you materialize this view, meaning create a table with all this data, and then instead of querying a query, you query the actual data. Did I get it right?
Exactly. Yeah,
Yes.
that's correct.
Okay, what do you think about Scala? Does somebody like Scala? I think Ankush likes it.
I think Scala is it's definitely one of the best languages out there for data engineers. The biggest part is it's type safe and it's not as heavy or as verbose as Java. So Scala has like a perfect combination. At least for me, coming from Java background, I love Scala. And for like, I would say yes, it's kind of an important language to know as a data engineer, especially because Spark is written in Scala, and sometimes when you see errors which are very Spark or Java native, you might get confused if you do not have any knowledge. So I like Scala personally. I use it for developing some pipelines also. I also use it to write code in Spark and sometimes also in Beam. But do you actually need it? No, not really. If you know Python well enough and you are very proficient in Python, you can get away with minimum knowledge of Java and Scala, I would say. Unfortunately, but I would say I like Scala personally. So if you like it, definitely go ahead and learn it. It's really a good language.
But I think you get some performance benefits because Python is sort of like, it's an extra layer of abstraction on top of Spark, right? Which adds a bit of overhead. And there are some cases when you want to have more control over things, right?
So in my personal experience, whenever we have written bad jobs, I'm not talking about real time. I'm talking about bad jobs, which doesn't matter how much time it takes. It was always more than half an hour, 10, 15 minutes minimum, right? So adding another 30 seconds or 1 minute because of this Python performance doesn't really matter. So in real time streaming, yes, this would be a huge loss, but I don't think so. That's the case with PySpark in real time. But in batch, it doesn't really matter. This performance benefit is
serialization is better when you use Scala, because in Scala you can use these case classes or whatever they are called, and then you can easily turn your RDD to this case class. And I think this uses some very efficient serialization mechanism, which you do not have in Python. And while sometimes it can be just a difference of minutes, but I remember we had a case then the difference was like 20 minutes. When we took a pipeline and rewrote it in Scala, the difference was big.
I would say that was Spark 1.0 something, because after the release of data frames and data set, that's also not really used.
No, it was with data frames. Yeah, it was 0.2. I remember that. And every step in our pipeline was, well, we used Python everywhere. And when we found this one job that we could optimize with Scala, yeah, the whole pipeline was a lot faster. But like it was something like I needed Scala only once in a year of using Spark. So
yeah.
Maybe, what do you think? What is more important, to know Java or to know Scala for a data engineer?
If you are very good at Python and you would use once, then if you already know Java, don't learn Scala. If you don't know both, then learn Scala, because Scala is very much easier to learn in that case, especially for Spark.
Okay, I will not argue with that because we don't have a lot of time. I have a very strong opinion about Scala.
I have my own preferences. I am biased here, to be honest. I really like Scala, and my answers are not neutral. They are definitely biased towards Scala.
Okay, I will mark it as solved. Victoria, you didn't want to add anything, did you?
No,
I
don't know. I haven't used Scala in several years, so yeah. For some reason, people still offer me jobs as Java developers in LinkedIn. Only so. No, nothing to add.
Do you miss it?
I guess no. I use it at university because I had to approve to get the title. I would not use it again. We look at I guess this one's for me, right? We look at quite simple examples using DBT. What about complex business logic? I'm not sure what to answer. I mean, yes, you can do, definitely. I'm not adding that part. I'm not adding that as part of the project, at least not in the workshop. And the reason for that is because we want people to learn, and we have to also have in consideration that people are entirely new to this concept. So I thought it would be too much in overhead to try to cover things that are already even quite complex on a day-to-day. So even for me that I work daily with DBT, I wouldn't say that I do, I work with a slow changing dimensions on a daily basis, for example. So that's also why I think it's something that you would look at the moment you use it. But you can definitely do that with DBT, especially deletions after implementing a loader step. This can be done with hooks. I linked this in there's like a section that I did like with advanced knowledge, and I link hooks. I link incremental models that I mentioned before. As only changing dimensions, I didn't link it, but I could link it. This is something that you could use with the snapshots, which I think I added as a concept. Then updates, I guess you could do it also in a pre-hook or in a post-hook. But this is also something that you would do with an incremental model. Incremental model, when it loads that new chunk of data, you can use a merge. Or you can do, depending on the workers that you use, it could be an insert and an update. So that's something that would work on a unique key. But yeah, and I mean, this project and also the final project is up to you. Like the more you understand, the more complex you can go, and there's no limit. I hope that answers.
Oops, I think I accidentally.
Yeah, one more, right?
Yeah, so I didn't mean to do this, but
what was it?
I think I have a.
I think it was. No, I think no, in our company.
Archive, okay. Are we distant from what a data engineer, let me enlarge it. Are we distant from what a data engineer day-by-day work looks like? What are the main difference? I guess the difference between what we are doing here in the course and the actual work of a data engineer.
More problems. More troubleshooting, probably.
No, I think the course is made in a way to set you up for becoming a data engineer or tackling all the problems of a data engineer. Mostly, it will revolve around these technologies which we are talking about.
So, what are the main differences, except for more troubleshooting? And then maybe I imagine that there are analysts come or other people with ad hoc queries saying, "Hey, where is this data? Where this table is?" Right, and then you have to help them. Right. What are the other main differences?
I would say complexity.
Mm-hmm.
Definitely.
Yeah, we have a relatively simple case, right? So we only need to do like one join, well, 2 joins. So we have one table with, well, a bunch of tables. But these big tables, we don't need to join them with each other, right? We only do join with location table, which is pretty small. But in practice, we often have 2 big tables that we need to join, right? Or
yeah, we don't have complex business logic. Yeah.
Yep.
Plus, you don't really do the setup all the time, right? I think there's a lot of, like, you set up BigQuery once and then you maintain it, but you won't be dealing probably with service account that much and stuff like that like now.
Or ideally, maybe there is a team who's dealing with that, right? So for example, at our work, we have a team who manages Airflow. So I don't need to worry about this. So all I do is I just write docs, commit them, and that's it. So I never had to to set up Airflow locally and worry about these things. So because it's managed. And I think the same with data warehouse and other things.
Yeah, big plus.
And I think one more thing which I think everybody with data does is basically communicating outwards what is the meaning of different columns, or what is this ratio versus that ratio, and all that. I don't know. I have to personally do that a lot. What's your experience like there?
So I would say the same. There's, of course, especially for business stakeholders, but we also, DBT has this data catalog part. So in the data team, I would say that helps quite good. And we're looking and working on the selection of an actual data catalog. So hopefully not so many questions.
Yeah. So in our case, these questions, we have a catalog team. So we have some internal catalog tool, and this, they get all these questions, not data engineers. Okay, so I guess we can move to the next one. So how Data Vault differs from, sorry?
I know, so I'm about to read it. Go ahead.
Okay. How Data Vault differs from classic data warehouse concepts like cubes or star snowflake schemas.
I'm not super familiar with data. I don't know, Ankush, are you more familiar with Data Vault enough to answer the question? Otherwise, I could share my point of view.
I think you should go ahead. I have no clue about Data Vault.
So I bought a book about Data Vault, and it's called The Elephant in the Fridge. I found it quite nice to read, but I didn't read it all. And the reason for that is because what I saw with Data Vault is that there was no practical use from my point of view and the work I do and all of that. My understanding is that it generates an extra layer, and then you have something else like the data mart. So instead, right now we have a warehouse where we load the data and then we transform it there, and then we build something like the data marts or the star schema or something like that, depending on what you want to build, right? Like the data modeling concepts that you want to apply. And all of this lies in our data warehouse. From what I understand from the Data Vault, and sorry if I'm understanding this the wrong way, it's like it generates an extra layer before your and then you have something else like another database or something that's like the data marts, and it tries to denormalize the data similar to what happens with the star schema, but the reason or like the solution they're looking for is that the star schema is too difficult to understand. So they first define the business like the business need, and then they accommodate that, and then they have similar concept to the star schema, but they accommodate that, and then they generate this extra layer. And this is the main difference from what I understood. But probably go and Google a little bit more. I also don't know companies that use it, to be honest. I've never met anyone that I could have a conversation on how this looks like in real life.
And Vault is, what exactly does it mean? Like this is a place where you keep things, right?
Yeah. Which technically is a data warehouse, but you cannot get out.
Okay.
It's not the way that, and so you have this, the Vault is like this extra layer that I'm saying is that where you have this data, and then you don't expose that data, that doesn't get out of the Vault, the data, except for those marts. And they do it more similar to the concept of data marts. They have it more on the business process, kind of like group by business process. Yeah, I can share the book that I read, but not much more than that.
It was something with elephants, right?
Yeah, the elephant in the fridge, it's called. And the reason for that is because the fridge can be also called a vault, and it's quite nice. It looks like even And the reason for that is because the fridge can also be a vault. And then it's like, yeah, the elephant in the fridge. And it's not from the creator of the data vault, it's someone that actually explains what the creator, and I found it very useful and like very clear written. But that's all we can.
Okay, thank you. So is it always a good practice to put data in data lake before putting it into data warehouse like we have done in the course exercises?
So I can try. Is it always a good practice? No, obviously not, because there's never always one way of doing things. But in some cases, this definitely makes sense. So for example, let's say you are using Snowflake as a data warehouse, and that's a very expensive data warehouse, honestly. And in those cases, you might want to keep a data lake layer for machine learning solutions. That would really help you to cut down your cost and even maybe like, let's say, remove some data later in the data warehouse if it's getting too expensive or something. So there are definitely use cases in which I would definitely recommend everybody to have a data lake before a data warehouse, but not in all the use cases. If you are a small company or you are having a very small data set and you want to be quick, then putting an extra layer of data lake might just have a negative impact on the overall performance and speed.
I'm thinking of any data we have in our company that goes directly to data warehouse, and I don't think we have anything. So everything first goes to data lake, and then some of this data might end up in a data warehouse. But let's say only 10 to 20%, and the rest stays in the lake.
Yeah, and I think that's because your company is very mature in using data. And your company is also very mature in saving this data, because generally when in a lot of companies, the maturity level is not that much. And in those cases, having a data lake might just create a data, mesh, a swamp, basically a data swamp later on. So.
Okay, Victoria, should I mark this as answered?
Yes. I would ask my data engineer. Ankush.
So does anyone have any experience with Azure Data Factory?
No.
Unfortunately not.
Yeah, but I guess this is some sort of managed solution for doing ETLs. And if it is, then the advantage is, well, you don't need to manage Airflow, because for Airflow, you need to host it somewhere. Somebody needs to look after this. I don't know, if your DAGs don't run, then somebody needs to go there and check why they don't run. Could be you, right? Do you want to do this or not? And if it's a managed solution, then then all this headache goes away. So, but I don't know how flexible it is. Yeah, so that's the advantage. Yeah, but also disadvantage that Airflow can do a lot. And Azure Data Factory might be quite specific to Azure, right? Maybe you cannot do things that are outside of Azure, but I'm just speculating. I have never used it.
Actually, it turns out that it's like the cloud version of the information service. I think it is from SQL, but I've used it in the past, and I would say I'm also not like a super expert with Airflow, but it's definitely flexibility. I'm guessing it's better now in Azure and all of that, but the problem there is that you needed to have the SQL Server and all of this. It's like you're limited in the sources that you can use. You're limited in the things that you can do, and it wasn't like super easy. You don't have a DAG, like you can generate it yourself. Like you can generate like all these steps, but it's not that clear from at least my experience using Airflow. And then using SSIS.
Azure Data Factory is something similar to this integration SSIS, right?
Yeah, turns out that it's like the cloud version, kind of. It says Yeah, that it's looking to modernize SSIS.
Okay. Yeah, I remember the first time when I saw this SSIS, I was like, why did I spend all this time coding things in Java if I could just drag and drop things and connect them with errors and it just works? And the answer is that it just doesn't always work. Sometimes you need some flexibility, and then that's why you need these Java developers who would go there.
100%.
Yeah. Okay. Has somebody used Nifi? Or it Nifi? How do I actually pronounce it? Or Nifi?
No idea. Apache
How would you
Nifi.
pronounce it if it was Nifi? I would pronounce it as Nifi.
I think it's Nifi because it's caps N, caps F, which means it's like 2 words. So it must be Nifi, but I would say Nifi, to be honest.
So I guess it's similar to this SSIS, Talent, and other things, right? Or no?
Yeah.
Oh, it's streaming analytics, batch analytics. I have no idea. So there are so many data tools these days. It's hard to keep track of. Like even in Apache, this under Apache umbrella alone, there are so many data tools that it's just not possible to know all of them.
Yeah.
Okay, should I move on?
Yeah. We also have 8 minutes, so.
Right. So that's about DBT.
For DBT, you organize the transformation as a stage processing presentations. Is this architecture typically used, or are there more layers? I would say yes, this is the go-to. Not just DBT. Yes, DBT enforces this, and if you will, like if you go and read their viewpoint and all of this, like they'll explain that they also do the models like with this kind of a structure. But as I mentioned in the modeling concepts, this is a concept that comes like from the 80s that Kimball defined. With the kitchen analogy, I find it very, very useful. And this is normally how you go. Of course, the more complex it gets, you may need more steps, and that's okay. But always try to have this separated. What is the presentation? What is the source that you'll need to do some typecasting, like we do, for example, maybe some deduplication. And then in the middle, you may have more models that will go and that data, like in that pipeline, let's say, in that flow. But this is more or less how it would look like.
And what is this kitchen analogy?
The kitchen analogy is that the way you model your data is the similar how the restaurants they model their food. You have like the warehouse where you should have raw food, and this is where you have your source data. Not everyone is allowed to do that. In fact, it's actually dangerous, and that's why for some reason there are like security measures about who can actually go to the warehouse, what can be stored, and how can it be stored, and things like that. Then you have the kitchen, and only the people that can cook this raw food and made it into food like that they're going to serve are allowed there. And this would be the data engineers and the data analysts maybe, and the analytics engineers. And this is what you will be doing in the data warehouse, trying to process that raw data. And then at the end, you have the part of the restaurant where people eat, the dining hall. And this is the presentation layer of your data warehouse. This is how like your doing fact tables will look like, or data marts if you're building data marts. And these are the business stakeholders are only like everyone is allowed to get that food, let's say. There are no restrictions, but it's only already presented. You're not presenting the raw.
Yeah, and I think we have this Tableau self-service tool where we can go and do this all cubes and all that. So this is the presentation layer, right?
Yeah. So technically, in the BI tools that are self-serve, you could have everything. You could expose everything. So right now we have the external tables Then we created our own tables in the trips data hole, and then we create the station model, and then we create the fact trips. I could have everything in there. I could even have the ones in my development exposed to the self-service tool, like the VI tool, like Tableau, Look, or whatever. But this analogy, what it says is that you should use the presentation layer only and not the other parts, because that's the data. If you present the raw data, then people wouldn't know how to use it. And then it's going to be like, oh, I don't find this zones or this other zones, and maybe it's because there was no transformation and things like that.
Yeah, nice analogy. So I'm starting week 3 now. Please don't feel dumb. You can feel left behind. Yeah, do not feel left behind or dumb, because well, you can always ask questions in the chat. In the channel, you can also look up things. And I don't know what's the state of our list with frequently asked questions. I think it was abandoned, but maybe we can put some light there. So if you have a question, while we still have 10K history in our Slack, so if you have a question, look it up in Slack, and then if you find the answer, please put it to frequently asked questions. This way it will be preserved. And yeah, of course, please don't feel dumb, because everyone has a different amount of time that they can dedicate to the course. Everyone has different background, right? So somebody, maybe for somebody it's the first time they use Docker, and for others they've been using Docker for the last 5 years, right? Of course, for the second group of people, it's easy, but it doesn't mean that it should be easy for you, right? This is yeah, please don't feel dumb. Anything to add? Okay, I'm using Docker setup locally. Downloading lots of data for week 3 is not possible. Should I set up everything on GCP VM or use transfer service? Well, up to you. If you have AWS account, you can go with transfer service. That's probably easiest, because you'll just need to click a few buttons. With setting up a GCP virtual machine, you will need to spend some time setting everything up. It's worth doing this, because for other weeks, so for week with Spark, probably for Kafka as well, it will be useful for you. So probably it is worth the time investment. But if you just want to quickly copy the files, transfer service is probably the easiest way. Okay, I treat silence as nobody wants to add anything.
It's a yes. Yeah, and 2 minutes left.
So can only be transferred using transfer service. I think, Ankush, the way you did it, you just stopped it, right? So you started using transfer service, and then you stopped it when it transferred this data, right?
Yeah, it will automatically stop. But you can also use prefixes. There are some options to use prefixes and filters, and you can definitely try to use them.
Okay. How do you productionize dbt with Airflow?
There's a package. There's a dbt package. So there are 2 ways. If you use dbt Cloud, you could actually from Airflow trigger a shop in dbt Cloud that you already have in there. So it's something similar. So for example, we created some shops in there to run everything. I could from Airflow, that shop will have an ID, and I could trigger that using my credentials as well from dbt Cloud. That would be the easiest way. But I'm guessing this is targeted to just using Airflow as a scheduler and not dbt Cloud, which is completely valid. And for that, there's a package that you could use. And there's another thing, which is, I'll share the link here, and it says invoking dbt through the bash operator. Where should I share the link?
Zoom, please.
In Zoom, okay. So in this page is the official documentation on how to run dbt in production in general, and one of the options is to do it via Airflow. So you can check it out, and there's the link of this package, and also the link to an explanation of how to use it via a bash operator. And you can also check out the other ways, I guess. Like, for example, I suggested using cron if you're working locally. This is also something that it's there, like not as fancy as having like an Airflow setup, but cron never fails.
Well, Airflow is nothing but a fancy cron, right?
Yeah,
well,
exactly.
That takes some time to run. Okay, do we have time to take the last one?
I think it's also quite an important one, right? Like I saw a lot of questions around this, so I think it's worth it.
Do you know the answer?
Yeah,
it's up to you. Ankush,
So I don't know the answer to this because I tried it with CSV only and didn't try it with Parquet. So the thing is, with CSV, it automatically detects it as date time, and with Parquet, the date fields are converted into byte array. So I think I've seen this issue multiple times on Slack, and I have not solved it right now. And what I can suggest is that I can try it, and I can maybe then put the solution on Slack there.
I think the problem with this one is because you already have schema embedded in your Parquet files, right? And then if BigQuery sees that in one Parquet file you have one schema, and then in other you have a different type, then it kind of doesn't know what to do with this, right?
Yeah, that can definitely be the case.
I guess that's all for today. So thanks a lot to everyone for answering questions. Thanks a lot for asking questions. And so this week we are doing dbt, and then the next week will be Spark, right?
Yeah, and the homeworks, because I saw that there's another question here, it's about that. The homework for duty is due the 21st. And today, maybe tomorrow, once we have a video, BigQuery, week 3.
Yeah. So that would be it for today. And goodbye, everyone. Have a great rest of your day.